Hi there, friends and neighbors. I'm going to show you a complete example of a one-way ANOVA results section. Now we've got all the components here of your typical results section. Descriptive stats. This is going to be means, standard deviations, and sample sizes for each group. Graph, which is part of the output from R. And the inferential stats. You need HO, H1, and alpha. You need your assumption check. Confidence interval, test statistic, degrees of freedom, p-value. You need your decision about HO and interpretation of the confidence interval if appropriate. We will not have a confidence interval for this one. And then interpret in plain English. Now, if you have a significant ANOVA, you need to follow it up with pairwise comparisons to find out what causes those differences. And so that's something else we'll be covering. Okay, so I'm going to go ahead and get started. I've got a data set already loaded. They're called data cubed. And what they wanted to know is if people take some or mostly or no online classes, what is their GPA? Is there a difference in GPA among those groups? So let's start with the descriptive stats. Statistical analysis, continuous variables because GPA is quantitative. Numerical summaries. I'm going to look at GPA. I'm going to summarize by my category, which is some, all, mostly, or no online classes. Now click OK. Okay, little, mostly, and some online classes. Those are the three groups. The sample sizes are 41, 7, and 29. It's too few. Copy. And I'm going to paste it here. Okay, I'm going to select that table and make it Courier New. The graph we're going to get when we run the analysis. Let's just go ahead and jump into HO, H1, and alpha. So HO, all population means are equal. In other words, it doesn't matter whether you have some, mostly, or little online coursework, your GPA is the same about. In the population, it's the same for all three. H1, at least one pair of means is different. As you can see, we've got three groups here. That's why this requires ANOVA and not just a two-sample t-test. And then alpha, you can pick anything you want, but pick 0.05 is the typical one. And the assumption check is kind of complicated. So for an introductory class, I just don't take it that seriously. But let's just say it this way. For each group, we need the variable to be normal or n at least 30, a large sample size. We need variance to be about the same for all groups. And that's about a ratio of 1.75 from the largest standard deviation to the smallest, which I can check that right now. 0.4 is the largest and 0.34 is the smallest. So let's get a spreadsheet open to do that computation. There's the largest, here's the smallest, equals this divided by this, and we got 1.18. That's actually acceptable. 1.75 would be our threshold. Maximum standard deviation divided by minimum standard deviation equals 0.40 divided by 0.34, and that's about 1.18, which is less than 1.75, so this assumption is met. As far as the n of at least 30 for all three groups, well, the mostly group has only 7. The other two are okay. 29 is not quite 30, but it's close. It's really this mostly group. So what I'm going to do now is make a histogram for the variable and see if it's normally distributed. I'm going to ignore group membership because under HO, they're all the same group. So make a histogram of GPA. Look at it. Oh, that is very far from normal. Okay. The variable is skewed left, and one of the groups has n equals 7. So we do not meet the assumptions. And I'm sorry about that. And really, at this point, we should stop the analysis. But we're going to continue anyway because I want to show you how to write one of these things. So let's see, we have normality, linearity, independence, homogeneity, variance. Those are the four assumptions. I'm going to leave it at this. That's close enough. We already know we don't meet the assumptions anyway. And we should not be doing this. for any practical purpose. All right, now there's no confidence interval, at least not the way we're going to do it, so don't worry about that. Here's the analysis: statistical analysis, continuous variables, one-way ANOVA. You choose your response variable as GPA, and the grouping variable is category. And all the other options, we do need to choose something for follow-up comparison. If we reject HO, I need to do pairwise t-test, that is pairwise on each, a t-test on each pair of means to see why, to see exactly which one is different. And to do that, I'm going to choose the two-key follow-up comparison procedure. You click OK, and you get your graph. It does not appear to be different. Here's another graph. I'm going to go ahead and put this graph in there. If you have Windows or Mac, you can just right-click and copy it. I have a little bit of a different situation, so I'm not going to right-click. I'm going to do it the way I'm doing it, which is not too bad. Cut, go back to the Word document, paste, right-click, anchor as character, make it smaller, cut it, and move it to the graph. There's my graph. And I don't see any difference between those three. Let's go get the ANOVA summary table, which is what you get. That's the results from this kind of analysis from a one-way ANOVA. I'm going to scroll up until I get to it. There's the ANOVA summary table. Copy the whole thing, paste it. I'm going to give myself some space to play with. I'm going to select the table, the whole thing, and change it to Courier New so that it's monospace font and it looks good. So we see I've got 2 degrees of freedom and 74 degrees of freedom. Our F is 1.087. The p-value is 0.343. Make my decision. P-value is greater than alpha, so we fail to reject HO. We conclude that there is no evidence to support the claim that amount of online education is related to GPA. Apparently, you get the same GPA irrespective of those three groups. Now, if we had rejected HO, we have to find out why, and that's what this two-key follow-up comparison procedure is about. You would look at the 3 possible pairwise p-values, mostly minus little, some minus little, and some minus mostly. And you look at these adjusted p-values, and whichever one of those is smaller than 0.05, that's the group that is significantly different. In this case, there are none, because there are none. Just out of curiosity, I'm going to try the other variable. Satisfaction. Still, no difference there either. Okay. And the p-value is 0.333. Anyway, that's a complete results section for a one-way ANOVA from beginning to end. All right.